Not all modern wire is rated for 90 degrees Celsius. It's crucial to determine the wire's temperature rating, especially for applications like recessed lighting where heat buildup is a concern. The primary way to determine a wire's temperature rating is to check the printing directly on the wire's insulation. This printing should explicitly state the temperature rating in degrees Celsius. Look for markings like 90 degrees Celsius. Common wire types suitable for recessed lighting due to their 90 degrees Celsius rating include THHN and THWN. If the printing on the wire is smudged, illegible, or otherwise impossible to read, there are a couple of alternatives. Firstly, consult the wire manufacturer's specifications. The manufacturer's datasheet or online resources for the specific wire type should clearly state its temperature rating. Secondly, in some cases, an insulation resistance test can provide indirect clues. An insulation resistance test using a megometer, also known as a megger, won't directly reveal the temperature rating, but it can help assess the integrity of the insulation. Deteriorated insulation, which might be due to overheating, could indicate that the wire isn't suitable for high-temperature applications. Keep in mind that this method is not a definitive way to determine the temperature rating, but it can highlight potential problems. Recessed lights generate a significant amount of heat, and therefore, they require wire that is specifically rated for at least 90 degrees Celsius. This high temperature rating is necessary to prevent the wire insulation from melting, cracking, or otherwise degrading over time, which could lead to electrical shorts, fires, or other safety hazards. Wires commonly used for recessed lighting that meet the 90 degrees Celsius requirement are typically labeled as THHN or THWN. THHN stands for thermoplastic high heat resistant nylon coated. It is a popular choice for general purpose wiring and is often used in conduit or other raceways. THWN stands for thermoplastic heat and water resistant nylon coated. It is similar to THHN, but also has moisture resistance, making it suitable for damp or wet locations. If you discover that the wire you are using is not rated for 90 degrees Celsius, it is imperative to take immediate action. Firstly, replace the wire with wire that is specifically rated for 90 degrees Celsius, such as THHN or THWN. Ensure that the new wire is properly sized for the circuit's amperage and voltage requirements, consulting the National Electrical Code, or NEC, for guidance. Secondly, if you are unsure about any aspect of the wiring or are not comfortable working with electricity, consult a qualified electrician for professional guidance. An electrician can properly assess the situation, identify any potential hazards, and ensure that the wiring is installed safely and correctly. Using wire that is not rated for the appropriate temperature can have serious consequences. It can lead to electrical fires due to the insulation breaking down and causing short circuits. It can also create other hazards such as shocks or equipment damage. Therefore, it is absolutely crucial to verify the temperature rating of your wire before using it for recessed lights or any other application where heat is a concern. The NEC contains various tables and articles relevant to wire temperature ratings and ampacity. For example, NEC Table 310.15b16 provides ampacity ratings for various wire types based on their temperature rating and size. It is important to consult this table to ensure that the wire you are using is adequately sized for the circuit's load. Additionally, NEC Article 410 covers the requirements for luminaires, lamp holders, and lamps, including recessed lighting. This article contains specific information about the types of wiring and insulation required for recessed fixtures. When selecting wire for recessed lighting, consider the following factors. Firstly, the temperature rating, ensuring it is at least 90 degrees Celsius. Secondly, the wire size, ensuring it is adequate for the circuit's amperage rating. Thirdly, the environmental conditions, selecting THWN wire for damp or wet locations. And fourthly, the ease of installation, choosing a wire type that is flexible and easy to work with. When installing wire, be sure to follow all applicable electrical codes and safety practices. Firstly, turn off the power to the circuit before working on any wiring. Secondly, use appropriate tools and equipment such as wire strippers, crimpers, and voltage testers. Thirdly, make sure all connections are secure and properly insulated. Fourthly, inspect your work carefully before restoring power to the circuit. A megameter is an instrument used for measuring high values of resistance, particularly insulation resistance. It applies a high direct current voltage to the insulation and measures the resulting current flow. The resistance is then calculated using Ohm's law, which states that resistance equals voltage divided by current. A high resistance reading indicates good insulation, while a low resistance reading suggests insulation breakdown or contamination. When using a megameter, it is important to follow the manufacturer's instructions carefully. Firstly, ensure that the equipment being tested is de-energized. Secondly, connect the megameter leads to the appropriate points. Thirdly, apply the test voltage and record the resistance reading. Fourthly, interpret the results based on the manufacturer's guidelines or industry standards. The NEC defines ampacity as the current, in amperes, that a conductor can carry continuously under the conditions of use without exceeding its temperature rating. Ampacity is determined by several factors, including the wire's size, insulation type, installation method, and ambient temperature. Exceeding a wire's ampacity can cause it to overheat, potentially leading to insulation damage, equipment failure, or even fires. The NEC provides tables and guidelines for determining the appropriate ampacity for various wire types and conditions. When selecting wire for a particular application, it is crucial to consider the ampacity requirements and choose a wire size that is adequately rated for the load. In addition to temperature rating and ampacity, other important considerations for wire selection include voltage rating, conductor material, and insulation type. The voltage rating indicates the maximum voltage that the wire can safely handle. The conductor material is typically copper or aluminum, each with its own advantages and disadvantages. The insulation type provides protection against electrical shock and environmental factors. When choosing wire, it is important to consider all of these factors to ensure that the wire is suitable for the intended application and meets all applicable safety standards. Always consult the latest edition of the NEC and any local electrical codes for specific requirements and guidelines. Proper wire selection and installation are essential for electrical safety and reliability. Neglecting these aspects can lead to serious consequences, including electrical fires, equipment damage, and personal injury. Therefore, it is always advisable to seek professional guidance from a qualified electrician if you are unsure about any aspect of electrical wiring. Understanding wire temperature ratings is a cornerstone of electrical safety. Firstly, it prevents overheating and fires. Secondly, it ensures proper operation of electrical systems. Thirdly, it prolongs the lifespan of electrical components. Ignoring temperature ratings is a recipe for disaster, potentially resulting in property damage and putting lives at risk. The most common wire insulation types and their temperature ratings are as follows. Firstly, THHN, thermoplastic high heat resistant nylon coated, rated for 90 degrees Celsius dry, 75 degrees Celsius wet. Secondly, THWN, thermoplastic heat and water resistant nylon coated, rated for 90 degrees Celsius dry, 75 degrees Celsius wet. Thirdly, XHHW, cross-linked polyethylene high heat resistant water resistant, rated for 90 degrees Celsius dry and wet. Fourthly, AF, underground feeder cable, rated for 75 degrees Celsius dry and wet. Note that these are general ratings and specific manufacturer specifications should always be consulted. When working with electrical wiring, always prioritize safety. Firstly, to energize the circuit. Secondly, use appropriate personal protective equipment. Thirdly, inspect wiring and connections carefully. Fourthly, test the circuit after completion. If you are not comfortable performing electrical work, consult a qualified electrician. Electrical safety standards exist to protect people and property from electrical hazards. Firstly, these standards are developed by organizations such as the National Fire Protection Association, or NFPA, and Underwriters Laboratories, or ALL. Secondly, they cover all aspects of electrical design, installation, and maintenance. Thirdly, compliance with these standards is essential for ensuring electrical safety. Ignoring these standards can lead to serious consequences, including electrical fires, equipment damage, and personal injury. Understanding and adhering to electrical safety standards is a responsibility shared by everyone involved in electrical work, from electricians and engineers to homeowners and business owners. If you encounter damaged or deteriorated wiring, it should be replaced immediately. Firstly, damaged wiring poses a serious safety hazard. Secondly, it can lead to electrical shocks, fires, and equipment damage. Thirdly, replacing damaged wiring is a relatively simple and inexpensive way to prevent these problems. If you are unsure about how to replace damaged wiring, consult a qualified electrician. Electrical fires are a serious threat to life and property. Firstly, they can start quickly and spread rapidly. Secondly, they can be difficult to extinguish. Thirdly, they can cause extensive damage. Preventing electrical fires requires a combination of factors, including proper wiring, regular inspections, and the use of appropriate safety devices. If you suspect an electrical fire, evacuate the building immediately and call the fire department. Regular electrical inspections are crucial for identifying potential hazards. Firstly, inspections can detect problems such as damaged wiring, loose connections, and overloaded circuits. Secondly, they can help prevent electrical fires and other safety hazards. Thirdly, inspections should be performed by a qualified electrician on a regular basis, typically every few years. The frequency of inspections may vary depending on the age and condition of the electrical system. Overloaded circuits are a common cause of electrical fires. Firstly, they occur when too much current is flowing through a circuit. Secondly, this can cause the wiring to overheat and potentially start a fire. Thirdly, signs of an overloaded circuit include trip circuit breakers, flickering lights, and warm outlets. If you suspect an overloaded circuit, reduce the number of appliances plugged into the circuit or consult an electrician to have the circuit upgraded. Ground fault circuit interrupters, or GFCIs, are life-saving devices that protect against electrical shock. Firstly, they monitor the flow of current in a circuit and quickly interrupt the power if a ground fault is detected. Secondly, GFCIs are required in areas where there is a risk of water contact, such as bathrooms, kitchens, and outdoor outlets. Thirdly, testing GFCIs regularly is essential to ensure they are functioning properly. Arc fault circuit interrupters, or SIs, are devices that protect against electrical fires caused by arcing faults. Firstly, they detect abnormal electrical arcs and quickly interrupt the power. Secondly, FSIs are required in many areas of the home, particularly bedrooms and living areas. Thirdly, they provide an added layer of protection against electrical fires. Surge protectors are devices that protect electronic equipment from voltage spikes. Firstly, voltage spikes can damage sensitive electronic components. Secondly, surge protectors absorb excess voltage and prevent it from reaching the equipment. Thirdly, using surge protectors is especially important for expensive electronics such as computers, televisions, and audio equipment. Extension cords should be used only temporarily and should not be overloaded. Firstly, using extension cords as a permanent wiring solution is a fire hazard. Secondly, overloading extension cords can cause them to overheat and potentially start a fire. Thirdly, choose extension cords that are rated for the intended use and do not exceed their maximum amperage rating. Light-emitting diode, or LED, recessed lights offer several advantages over traditional incandescent or halogen lights. Firstly, they are more energy efficient, using significantly less power to produce the same amount of light. Secondly, they have a longer lifespan, lasting for many years without needing to be replaced. Thirdly, they produce less heat, reducing the risk of fire and improving energy efficiency. When installing recessed lights, it is important to follow all manufacturers' instructions and applicable electrical codes. Firstly, ensure that the fixtures are properly supported and secured. Secondly, use the correct wiring and connectors. Thirdly, do not overload the circuit. Fourthly, test the installation thoroughly before restoring power. Dimmers are devices that allow you to adjust the brightness of lights. Firstly, they can save energy and create a more pleasant ambience. Secondly, when using dimmers with recessed lights, it is important to choose dimmers that are compatible with the specific type of lights being used. Thirdly, some dimmers are designed for use with incandescent or halogen lights, while others are designed for use with LED lights. Smart homes are becoming increasingly popular. Firstly, they offer convenience, energy savings, and enhanced security. Secondly, many smart home devices can be controlled remotely using a smartphone or tablet. Thirdly, integrating recessed lights into a smart home system can provide added control and flexibility. Voice assistants such as Amazon Alexa and Google Assistant can be used to control smart recessed lights, allowing you to turn them on or off, adjust the brightness, and even change the color with simple voice command. When planning an electrical project, it is always a good idea to consult with a qualified electrician. Firstly, an electrician can help you design a safe and efficient electrical system. Secondly, they can ensure that the work is done correctly and in compliance with all applicable codes. Thirdly, they can provide valuable advice and guidance. A permit may be required for certain electrical work. Firstly, permits ensure that the work is inspected and meets all applicable safety standards. Secondly, check with your local building department to determine whether a permit is required for your project. Thirdly, failure to obtain a required permit can result in fines and other penalties. Electricity is a powerful force that can be dangerous if not handled properly. Firstly, always exercise caution when working with electricity. Secondly, follow all safety precautions. Thirdly, if you are unsure about anything, consult a qualified electrician. Staying informed about electrical safety is essential for protecting yourself and your property. Firstly, take the time to learn about electrical hazards and how to prevent them. Secondly, read articles, watch videos, and attend workshops. Thirdly, share your knowledge with others. By working together, we can create a safer electrical environment for everyone.